Running totals, also known as accumulated totals, things like month to date and year to date, are very easy to do in Snowflake. And in the first 5 minutes of this video, I'll show you how it's done. And then if you stick around to the end, we'll go into great detail and make you an expert. So let's go. Hello and welcome. I'm SQL Dan. Today I'm going to talk about running totals. Now you probably have guessed that in order to calculate a running total, we need to use the sum function. And you've probably used the sum function many times before. However, in this case, we need to use the analytic sum function, not the aggregate sum function. So what's the difference? Well, let's take a look at a traditional sum. And we'll just sum, say, the number of runs that were scored. And when we run this, we get a total of 693. So the important thing about this function, though, is that it took 162 records and it condensed it down to a single record, giving me the sum, adding up all 162 records. Now, the other thing that you've probably done before is perhaps that you also included a group by, like this. And when we run this, we won't just get one record, but we'll get one record per group, like this. So we can see that they scored 25 runs in March, 91 runs in April, and on down the line. But again, the function has still aggregated all of the records from March into a single record, all of the records from April into a single record. So how do we make it an analytic function? Well, the key is the keyword over. So instead of having a group by like we did here, we can just run it just like this. And we can see that we still get the same number, 693, but instead of just getting it one time, we actually received the 693 value 162 times, basically one on each record. So what this over keyword does, it says, well, compute the sum that I've asked you to compute, but instead of just giving me one time, put it on every record. Now you may think that that doesn't look very useful, and you're right. In this particular case, it doesn't. There doesn't seem to be any reason why we would want to repeat that number all the way down the list. However, if we instead could add a star to it, and we run this query, now you can see we're selecting all the columns, plus we get the sum along with it. So that's what this over does, essentially, is that it does not change the number of records that are returned by the query, but we're allowed to see this aggregation on each of the rows. And so that's the basis we're going to use to calculate our running total. Okay, so let's move on now and let's start to work on this. First of all, just a brief note here. We can see that we have an aggregation function and an analytic function. And again, the difference between the two is the keyword over and those two parentheses that you see. And those parentheses are important. In just a moment, we'll put some keywords inside of the parentheses, but even if we are doing it wide open like this, we still have to have them. Okay, so what I'm going to do now is I'm going to modify the sum function. And inside of here, I am going to add an order by. And we will go ahead and we'll order by the date field. Now this is going to change the behavior of the analytic function. Let's take a look and see what happens. Okay, we can essentially see that we already now have a running total. So if you just want a basic running total of your whole data set, all you need to do is add an order by inside of the analytic function, and that will accomplish it. And I'll talk just a minute about why it is that this does this. But we can see that in the first game, they scored 4 runs, and the running total is 4. In the second game, they scored 8 runs. 4 plus 8 is 12. Then they scored 9 runs. 12 plus 9 is 21. And on down the list, all the way through to the last game, when once again we see that 693 number when they scored 1 run on the last day of the season. So that is the most basic of a running total. But what exactly is happening here? Why did it do that? Well, this basically has to do with the principles of mathematics, right? The associative property says that you can take A and B and you can add them as A plus B, or you can add them as B plus A. It doesn't matter what order you put them in, you're still going to get the same sum. So in this case, the SQL standard says, well, an order by is not needed here, so if they included an order by, there must have been a reason for it. And they save us from having to type a whole bunch of other stuff in order to get our running total. So if all you want to do is get a quick view of how to get a running total, you've got that. But I'm now going to go into more detail. Okay, and one more thing before I continue is I'd like to point out that the order by that appears inside of the analytic function is completely independent of the order by of the query. So let's say, for example, that I wanted to order the records by, the attendance, for example. Okay, I can do that, and it does not alter the calculation. It's going to be a little bit difficult to figure out here, but let's take a look. Okay. So these numbers appear to be all over the map because it's still doing the calculation in date order, and then it's sorting the records by the attendance from lowest to highest. So you can have a different order by on your query than you're using in your analytic function. And also, if you were to have more than one analytic function, you also can have a different order by on each one. So it's very powerful. Okay, so let's talk about what's happening inside of this analytic function here. I mentioned to you that starting at the beginning and just moving on up through the whole data set. There are actually some SQL keywords that describe this behavior. And there's a lot of typing here, rows between unbounded preceding and current row. Now you may not notice a difference here because this is exactly the same thing that we had before, but essentially it says unbounded preceding, which means go all the way back to the beginning. There is no bound on how many records before we would like to see. Okay, and up only to the current row. And of course that's the behavior that we saw already because we noticed that on the second record where it was 8, it only included the record from here and up. And the same thing here. So rows between unbounded preceding and current row is the default anytime that you have an order by with the sum. So you don't have to type all that. But this is also going to be useful for us if we'd like to do running totals or if we'd like to get more creative and maybe like only know the sum over the last 10 records or something like that. Okay, so now that I've showed you this, let's actually do that. And let me show you rows between 10 preceding. So now instead of unbounded preceding, I have rows between 10 preceding and the current row. So basically we'll be able to see if they're on any sort of a streak at all. Okay, now in the beginning the records look exactly the same because there aren't 10 records yet here. But after we get down to record number 11, it's now only including rows number 2 through row number 11 because that's basically 10 rows back. And so it's giving us a running total for only the last 10 records. So in order to make sure the query's not really cluttered, we'll go ahead and remove the unbounded preceding stuff just to keep it so we can focus on what we want to do here. And now I'm going to introduce you to another keyword, and that is partition by. Of course, I have to spell partition correctly. P-A-R-T-I-T-I. No. And let me show you what partition by does. I'm going to put partition by month, and then we'll run the query, and then I'll talk about what the output is. Okay, so we can see here that I said partition by month, order by date. So the order by is still keeping the same behavior from before, where we have unbounded preceding up to current row. However, the unbounded is still bounded by the partition by statement. So the partition by says, look at the month field and only consider other records that have that same value in the month field. So for example, on the month of March, again, we see the same records that we started off with before, because this is the beginning of the season. 4, 12, 21, 25. But look at right here, when we get to April, it resets, and the running total is only 3, which is how many runs they scored on April 1st. And then on April 2nd, when they scored 4 more runs, the running total is now 7. So the partition by says, look at the value that's within this field and include all of the other fields in that calculation. But again, it's still limited by the bounding of the windowing clause. Okay. But now we have a running total for the month instead of a running total for the whole data set. And that's what I wanted to show you in this video. It's nice and simple. It seems to be more daunting than it really is, but this is all you have to do to get month-to-date sales, for example. If that's what you want, is just partition by the month and order by your date field, and off you go. Thank you for watching this video. I hope that you learned something, and I hope you appreciate it. If you like my content, why don't you consider subscribing to my channel as I continue to create more and more content showing you how to become an expert in Snowflake. This is SQL Dan saying thanks for watching.